Okay. Hi, everyone. Welcome to this week's Entry Live. Today, we're very happy that we have Nick Young and Amim join us today for the introduction to Ingress and Ingress controller. So, would you like to say hi to the audience?
Hi everyone, my name's Nick Young. I work at VMware and I am a maintainer on both on Contour, the Gateway API, and Envoy Gateway, which are all Ingress related things. Yeah, excited to walk everyone through some stuff about Ingress today.
And
my name is Ami. I work with Chinchi in our team at VMware, and I'm here to learn Ingress with the expert people.
Amim is also an expert in Kubernetes networking part, so we are very happy to have him here with us. And also, Nick Young has just come back from the KuberCon Hi, Jianjing. So Nick has just come back from the KuberCon 2022, and he shared about the Gateway API during the conference. And today we will spend most of the time talking about Ingress and Ingress controller. And if we have time left, we will move to the Gateway API. Okay. Okay. So Nick, would you like to start the introduction?
Yeah. So so I've got some tests set up here. Now I just wanted to talk through briefly a little bit though about what Ingress is. You can see the this is a sample Ingress object that I actually have running in a cluster that we can see on the right hand side. But an Ingress object is all about taking your stuff that's running in your cluster and exposing it outside the cluster. Usually that's to the internet, but it doesn't have to be. Now, so and it's pretty likely that a lot of people who are using Kubernetes have used an Ingress at some point. It's been around for a very long time. It's only recently graduated to GA. That's why it's V1 up here. Incidentally, if you are still using the V1 Beta 1 objects, you really should move to GA because you're probably on an old version of Kubernetes as well. Yeah, so it's all about just exposing services, generally HTTP services, on the internet. And so to do that, it has a few things. So the main thing here is this rule stanza that will sort of expose a host. Here we've got a contour test1.youngnick.dev. That's my domain name. And it says for that host, expose a HTTP and send the traffic to this service. There's a bunch of other stuff here. And also this TLS stanza says, please make it HTTPS as well. So so basically all this does is it takes the stuff that's running inside your cluster in the HTTP bin service in the default namespace and makes it available on the internet at this contour test1 youngnick.dev domain name. Now, there's a couple of things that are important to call out here. When you do this, this is only setting this up as far as your cluster is concerned, right? If you don't set up the domain name to point to the cluster or the load balancer that is upstream, we'll get to that in a sec, then the traffic won't get to your Ingress controller, and so nothing will happen. So I've already done all of that in this case. So this is actually a working domain. If you're watching the stream, you can go there right now and see the HTTP bin service and try it out if you like. So I think that's sort of the real basics of what an Ingress is for. So I guess as I kind of would like to give you a chance to do you have any questions at this point as the audience stand-in?
So I'm typing this address in the browser, and it should be like http / contour test1.youngnick.dev.
Yep. Is
right?
it working, or did I break something? Oh no, I haven't put the contour. Look, if we do this, where I'm in the default namespace, I haven't actually put them in there yet. So, whoops.
Okay.
We want okay, so we've created that Ingress. You can see that it got an address. That's the address of the load balancer. So now if you refresh, you should see it.
Yeah. httpping.org,
Yep,
right?
yeah. So this is a really helpful container that's actually really useful as running as a test, because it lets you pass through all sorts of. Hang on, let me switch my sharing to this one. Okay, I just switched my sharing to the actual thing. So this is really handy because it lets you, you can say, please get me a, please get me a 404, and it'll be like, you'll get a 404 back. Yeah, other. It lets you generate sort of all the methods, the errors, get images, all that sort of stuff. Just really handy little test tool that I like to use for this sort of demo.
Nick,
okay.
I have one quick question here. So you exposed your service on port 80, and looks like it's forwarded to HTTPS. Could you explain like how?
Yeah, totally. Yeah, let me
set
flip
up,
back
maybe?
to the other thing for a sec. Thank you for doing all the hard work here, Chinchi. Okay, so yeah, in here you can see the service is exposed on port 80, but we're doing TLS. What this means is that this is asking the Ingress controller to actually terminate TLS, and then send HTTP from the Ingress controller to your backend service. Now, the way that you do this is you need to have this. You can see this TLS stanza. It actually points to a secret name. You can see here that we have there's a contour test one service secret here. That's actually created by Cert Manager. Previously, here's one I prepared earlier. I created some certificates, and I have a working Cert Manager set up here that will do all of the hard work to manage those certs for us.
Cool, nice.
Yeah. So a good question though. That's that, and so it means that it's up to you how you how you do this. Most of the time, you consider your cluster internal networking to be relatively secure, so it's not always necessary to do TLS on the front side and the back side of the connection, but it is absolutely a thing that you can do. There are ways to do it with Ingress, but it's a bit complicated because one of the biggest issues with Ingress is that what I am showing you here is as much as the spec as it stands can actually do. Right, you can't do anything more fancy than have a TLS expose a TLS service. You can have multiple services backing it, and you can do some stuff with path matching and things like that. But in terms of like actually terminating things, your choices are TLS or no TLS. You can't say I want to do backend TLS or mutual TLS or any of the sort of more other advanced stuff that you might want to do. You can't. It's just not possible to describe it inside the Ingress object. That's one of the reasons why, if you use an Ingress controller, almost all of them have a custom CRD or something like that lets you do that sort of stuff. And that's why we ended up building Gateway APIs to build that sort of that stuff on top. So I think. Yeah, so I mean that's sort of a really, really basic one. One of the other things that's really important to understand is that in your cluster, so in order for this to work, you need to have an Ingress controller, a Kubernetes controller that watches for Ingress objects and takes actions for you and sets up the traffic path for you based on that. Sorry, hang on. Okay, my kids are playing with my dog. So I've already installed Contour in this cluster. Sorry, hang on. Okay. Anyway, I've already installed Contour in this cluster, and we can see it running here. So it's in the project Contour namespace. It's got a Contour deployment and then a series of Envoy deployments. So it's got an Envoy daemon set, a Contour deployment, and most importantly, an Envoy load balancer service. What this does is this sets up in the cloud that I'm using. It sets up a connection between this IP address and routing the traffic to the actual Envoy service. So that's how the traffic that you actually, when you and your browser at home actually go to contourtest1.youngnik.dev, your browser is actually looking up DNS for contourtest.youngnik.dev. It gets this IP address and then routes to the load balancer that's running in, this is a GKE cluster, runs in GKE, and then that sends the traffic down to the envoys, and then the envoys send the traffic down to the HTTP bin service. So right, I'll draw a diagram of this in a little bit. I've got a mirror board ready, but that's how the traffic flow actually works. And so in order for you, each time that you install a ingress controller in a cluster, it needs to set up this like traffic path. And so the when Contour does it, most of the, we use a service of type load balancer here. If you set up other ingress controllers, they'll probably use a service of type load balancer as well. That's one of the things that most ingress controllers use. In this cluster, I've actually also set up, the Ingress Nginx controller so that we could have two options. And so this has a separate load balancer IP that goes to the Ingress Nginx deployment. And so that then is described in this file, the contour test 2 one. You can see that this one says, and the way that you choose between these is with this ingress class name field, contour or Nginx. So now this ingress class name field is a little interesting. It's a sort of a modern update of an old annotation that we used to set. There was just a string, and so you would tell your ingress controller when it starts up, hey, look for this string in the ingress class annotation, and that's how you would have them. There's a little bit more complexity to it now, but I don't know if it's worth getting into just now. The important thing is contour test 1 is using the contour ingress controller, and contour test 2 is using Nginx. So if I okay, so now we should be able to go to contour test 2. This is not the same thing. This is actually a echo service that just shows you the stuff that you've done. Let me swap to that. So yeah, this is contour test 2. You can see this one's also HTTPS because I did the same thing with the TLS and using Cert Manager. But yeah, this is a slightly different service that just shows you all of the headers that you sent. Another super useful tool. So I've talked pretty quickly there and run through quite a few things. Is there anything that I need to explain more there, everyone?
It's clear to me so far, and for people who are watching this show, if you want to ask a question in real time, you can log in your YouTube account and leave your question in the comment, and we can see the comment in the real time and answer your question during the show. So for those who are first time watching our show, please remember to do that. Okay, guess we can continue.
Yeah. So I think there's some other stuff that we can do here that you can do here. Conceivably, we can change this ingress class name to contour, but I'd need to do DNS updates to make contour test 2 point to the contour load balancer, not the Nginx one, and that'll take like 5 to 10 minutes to propagate. So I don't know, but yeah, that's if you did want to swap contour test 2 to use contour instead, that's all you got to do is do this. And save it and apply it, and then that will change. That will expose this this host name on the contour load balancer. But yeah, as I said, because that means you've got to update the DNS for contour test 2. That means that until the DNS update happens, all of the traffic for contour test 2 will flow to this IP, and once you apply that change, then Nginx won't be serving it anymore, so it'll just 404. So yeah, it is definitely possible to change ingress class names, but it's not a very smooth process.
So in the Envoy or contour, you don't have a controller like the Nginx controller. The service in the load balancer goes directly to the pods from the demo set.
No. So let me switch to a mirror board, and I'll draw some boxes. This one. Okay. You see that one okay? Cool.
Yeah.
Okay, so let's draw some boxes. We want a cloud. We want a cloud because we're talking about the internet. There we go. Here we are. Okay, now we need a cluster. And that. Okay, now we need a now, so we're going to need some. So I'm going to leave the details of the nodes and everything aside, but yeah, now we've got we need a box here that represents our data path. So in Contour's case, this is Envoy pods. Okay, so in Contour's case, this is Envoy. In Nginx's case, it's Nginx. I'll talk more about the Contour case first. It's pretty similar for the Nginx case. So what you're doing when you install is there's Envoy, then you have a load balancer in the cloud somewhere that is requested by a load balancer service. And this sort of Kubernetes by itself does this for you. You don't need to do too much about it. So here, that's okay, so Kubernetes creates that for you or manages it. Then the traffic path flows here like this. Okay, so the traffic flows to the load balancer and Envoy. Now on the outside here, we'll have an IP, which is, hang on, let me grab the IP. Sorry, copy and paste turns out to be hard. Let's go here. It is 35. That's the actual IP of the load balancer I'm using right now. So then via other means, we make sure that we make sure that this DNS name is set to resolves to this address, which means that traffic to that DNS name will resolve to this and show up at Envoy. Now, but so if we're just running, yeah, sorry, go.
So the 35.244, is that the IP? Is that the external IP of the Ingress?
Of the load balancer, yeah, the load balancer that's running inside the cloud provider.
Oh, okay.
Yeah, so maybe I'll just put that a bit closer so it's clearer. And then so the traffic from the internet is going to come straight from the internet to that IP by looking up this domain name. Okay. So that's all fine. The service type load balancer is going to expose the envoys now, but the Envoy has no idea what it's serving and what it's routing until it's configured. And so in Contour's case, we have a separate deployment. We have a separate Contour deployment that configures the Envoy using Envoy's XDS API. Okay, so if you think about what I showed you before, inside the Project Contour namespace, there's a Contour deployment and an Envoy daemon set. And the Envoy, when it starts up, it actually connects to Contour, and Contour is serving a port, and that port serves the Envoy XDS protocol. And what happens is that when Contour starts up, it watches the K8s API. It sucks config from the Kubernetes API server into Contour and then translates that into XDS that Envoy understands, and then sends that to Envoy. So until you create an Ingress object, then there's nothing for Contour to do because there's no config. You create an Ingress object. And then that goes into the API server that then flows to Contour, that then tells Envoy that you need to for the hostname contour test1.yong.dev, you need to take that traffic and send it to the HTTP bin service. Come on, you can do this. There we go. And send that to the HTTP bin service. And then everything, all the networking knows how to do the return path for you. So, and then everything works and you see the thing. Now, the other thing that's important to note here is that, of course, you're terminating TLS at this point on the Envoy. So the Envoy also takes the secret that has the TLS details in it. And those go into the API server, then into Contour, then flow down to Envoy via the Envoy XDS protocols. So is that? I know it's a lot.
So you have like the control plane, the data plane,
exactly
separated here.
Yeah. So Contour is the control plane, and the data plane is Envoy. The nice part about doing it like this is that it's possible to manage these independently. So you can restart Contour to say upgrade it, or if something goes wrong with Contour, only the control plane stops working. What that means is while you're updating Contour, or if Contour dies for some reason, then Envoy will keep accepting traffic, but no changes you make will flow to Envoy until the control plane is running again. So it sort of separates some responsibilities and means that you don't need to sort of roll everything all at once. I mean, obviously, if you want to upgrade Envoy, and you're upgrading a daemon set, then each Envoy that goes away, it won't be able to route traffic. But Kubernetes knows how to roll a daemon set safely for you, so it'll do if you update the spec of the Envoy daemon set to say, hey, upgrade Envoy from version 120 to 121, then Kubernetes knows how to do that safely, and it'll do one at a time. And as long as you set up your Envoy daemon set properly, which we have put a lot of time and effort into doing, then you shouldn't lose any traffic while Envoy is upgrading.
So what happens if we have like an Nginx in this cluster as well?
Okay, yep. So I'll do, Nginx looks a little bit different. I'll do a side-by-side, even though the cluster is actually going to be the same. But the things will be a little bit different. So in the case of Nginx, it's actually a little bit different. The Nginx setup is that there's only a single pod that is the control plane and the data plane combined. But aside from that, it does basically the same thing. Okay. Let's change this. This one is, and then this is, and this one is, instead of HTTP bin, it's echo service. Okay. So in this case, it's mostly the same. We've got the update these two secrets and the contour ingress. So when you install Nginx Ingress, it also creates a load balancer service that exposes, in this case, this IP address. I'd already preset up the contour test 2 thing, so that's how it works. And then Ingress Nginx does the same thing. It exposes a Nginx process on port 80, and then there's another container running in there that manages generating the Nginx config from watching the Kubernetes thing. And so every time you update the Kubernetes config, it regenerates the Nginx config and tells the Nginx process that there's a new config there for it to reload. So it's mostly the same. It's just that the Nginx doesn't do control plane and data plane separation in Kubernetes terms. Like outside of the pod is a better way to say that.
So all the routing rules will be written in the Ingress Ingress.
Yeah. So all the routing rules are still written in Ingress, and that's one of the points of Ingress, is that it's you can configure completely different implementations that might have completely different languages to actually implement them if you went to the implementation itself, and do them in this standard way using the Ingress object. Okay, so yeah, so that's sort of the path in both of those options. You can see that most of it is the same. So I just, okay, doesn't look like we've got any other questions. So there's a couple of things I can show you now. One of the things I thought was, obviously, in both of these cases, in the contour test, so the contour one, we've got, we're exposing the HTTP bin service. In the Nginx one, we're exposing echo service. You can actually just swap those, by changing the ingress. So if we, I'll just swap back to my thing and show you what we do here. Okay, so on this one, if we have here, you can see that at the moment we'll leave this as the Nginx Ingress class. But if we change this to the HTTP bin service, as you would imagine, that's now going to expose, and then I apply that, of course. That's now going to expose the HTTP bin service on that same contour test 2 thing. So if you head to contour test 2 in your own browser, you'll see that contour test 2 now also shows HTTP bin org, same as contour test 1. I could probably show that on the screen as well. Sorry to keep swapping backwards and forwards so much, Gigi. Thank you for being the StreamYard operator. Yeah, so now you can see that contour test 1 and contour test 2 are both HTTP bin. And then, so if I'll leave it on here for a sec while I just quickly go and swap contour 1 to echo service. That. And then if I go back and refresh contour test 1, you'll see it's now the echo service and not HTTP bin, right? So, I mean, this is pretty basic Kubernetes stuff, but like that's one of the best things about it is that you can do cool stuff like that. You can also have multiple backends, and then it's up to the Ingress controller as to how it handles them. Most Ingress controllers will, by default, do like a round robin between them. So if we, sorry if okay, if we just do this. A little while since I did this, so I might be getting this wrong. Let me just check and see. Yeah, it looks like that's not working how I expected. So, hooray for demos. Yeah, so that's definitely one of the things that people want to be able to do is to have multiple backends and do a weighted thing between them. It doesn't work so well in Ingress because the spec just doesn't support it very well, and different people have done it in different ways. So that's one of the big things that we addressed in stuff like Contour's HttpProxy and the Gateway API as well. Sorry. Okay. So I guess the question I have for you both is like, what else would you like to see? Is there anything else that you'd like me to show, or anything else I need to explain about Ingress?
So far it's very clear to me. And probably we don't have any questions from audience right now. So can we move to the second part about the contours?
Yeah, sure.
I have one question in the paths. So when you said that the path you can like probably get on your URI and move these to filter the request to this URI, can you do things like headers and more specific filtering? Like
so the basic Ingress spec does not include like details to do that. You can match on path, And I'm just pulling up the spec because it's been a little while since I looked at the Ingress spec, to be honest. I've been all in on Gateway API for a while. You can match paths, you can match host names, and that's pretty much it. Now, that's not to say that Ingress implementations don't provide you with ways to do this. Sorry, I always struggle to find the actual API reference. It's been a little while. Okay. Where's the service resources? Ingress in the spec. So yeah, so basically, if we look at this thing, we've got rules here, and we've got the host and all that sort of stuff. And then there's the HTTP rule type, and you see here we've got paths. I don't have any path set in this one. It's matching everything, but in this paths one, you can say path type and then just the path. So the path field is literally just a string that is matched using the path type. So you can have some implementations support like regex for path type, some only support prefix matching, a few other things like that. But like that's basically, you can't do, using the base Ingress spec, you can't do header matching, method matching, or a bunch of other matching types that people really, really want and need. And so pretty much every implementation has their own ways to do it. Nginx has a lot of annotations that you can put on the Ingress object, because for a long time that was the only way to make this work. In Contour, one of the things that we wanted to do was to make it so that, the problem with annotations is that it's just a string, so there's no type safety, there's no type checking, it's not structured, and so there's no way to make some of this stuff a bit easier. And so one of the things that we did was we came up with our own CRD called, we originally made one called Ingress Route, and then we evolved that into HttpProxy. And HttpProxy does have the way to set all of those things. Sorry, I'm just pulling up the docs. I will share that screen. Okay. Here's the Contour website. So we have the HttpProxy, and so the HttpProxy. So here's a sample Ingress object. Here, just like we talked about, basically you've got a prefix path, you've got a host name, very simple. Now for HttpProxy, you can do that. It looks very similar. We set the virtual host in a field of its own, and then we have routes, and the routes have conditions. So in this case, we've got we have a condition that's a prefix path match, and that sends to the service that's named S1 on port 80. But we have. So I'm just looking for. So we have a few other things that you can do. You can have you can mix and match conditions. Now you can do this in Ingress as well. So in this case, in this one here, you've got the slash the root path is going to this valid service, and the slash subpage is going to this service that doesn't exist. Now, obviously, usually you would want to have a service that existed, but when that happens, what happens here is that as you can do in Ingress and as you can do in pretty much every implementation, this sort of very basic path-based discrimination means that requests to www.example.com/subpage will be forwarded off to this service that doesn't exist. So because the service doesn't exist in this case, Envoy will actually respond with a 503, a service unavailable. If that service did exist, then subpage would be sent off to a different Kubernetes service. And one of the things that everybody's implementation does by default is that that path, when you send that path to your service will actually see the request as www.example.com/subpage. Now, a lot of services expect to see their requests come in at the root path at /. And so one of the things that we added to HttpProxy is that you can rewrite that path. So let's. I think I've actually got a Yeah, here we are. There's a better, you can rewrite that path. So what you can do is you can say, okay, so for any route, when you match the thing, so if the conditions match, in this case there's no conditions, so they'll always match, you can rewrite the path and replace whatever path was matched with some new prefix. And so in the case here, we've got a rewrite.bar.com domain name that is routing traffic to /v1 API and replacing the /v1 API route that you're going to get to /app/API/v1. And so what that's going to mean is that when you route traffic to this v1 API, what your app will actually see is is requests arriving at /app/API v1 instead. Now, a more usual way to use this is to do to say, okay, I want this app to be exposed at the usual one that I use is /API and /blog, right? Like you've got, and the marketing team say controls the blog, and the API team controls the API, and so the marketing team has a look, I'm going to illustrate this in code rather than trying to talk you through it.
Does it mean that the proxy, the HTTP proxy is like a more flexible or advanced ingress?
Yes, I would say so. That's in what it's intended to be. And so if we have a look at here's our HTTP proxy. We're going to do it as bar.com. Okay, so in this case we've got a service here that's goes to blog. The match is the /blog prefix. So what this means that request to bar.com/blog will match this condition and they'll be sent here. And so instead of so what we want to do is have it be, instead of that going to that, as far as the app is concerned, instead of it going to /blog, the blog service in the default namespace will see the request come in as the service will see the request come in as just bar.com, right? That path will actually be removed from the HTTP request by Envoy. Envoy will mess with the request magically for you, and your app will just see what it expects to see. So that means you don't have to configure your blog app to know that it's being served out of /blog. Is that clear, or am I being confusing?
It's clear to me, but why we want to do that? Why can't we just like define the stash to like which service? But why we want to do the replacement?
The reason you might want to do that is that if you want to do something like this, the simplest way is just to say, okay, the / goes to one service. But what happens if you want to use on bar.com? You want to expose multiple services. Okay, so we want to do something like this. Okay. So now you've got bar.com is the virtual host, is the actual host, name of your company, and you've got you've got a blog and you've got an API, right? And you don't want the blog and the API to go to the same like web service. And so in this case, what's happening is the /blog URL is going to blog, the blog service, and the /API URL is going to the API service. And that means that for your I'm assuming that the API here is like some sort of RESTful API or something like that. But that means the team that owns this API service, they don't have to worry about handling requests to /blog, right? Like all the requests they're going to see are only API requests. You don't have to have some other service that does this for you. This service will pick where the HTTP traffic should go for you. And so I mean, it's pretty common if you're doing that sort of thing to have like to have another one that will be like it'll just be the site, right? Okay, so this one means that if you make requests to anything other than /blog /API, right, then it'll go to this site service instead. That's probably going to end up being like a static service or something like that just serves you, just serves like your main website. right? But what this means is that these different things are broken up into different services. Yeah.
So they will be routed to the same page from different service because of the replacement.
Yeah. So they'll be routed to the same path on the service, right? So remember that this is gonna change things from the service's point of view, right? Like, so if you don't do the prefix replacement, the requests that come to the blog service will be to bar.com/blog.
Yeah.
Right. And so unless you have configured the blog service to expect that all its requests will come in on /blog, it'll be like, I don't know about this blog path. I'm expecting everything to come in at the root path.
Mm-hmm.
And so, and maybe most importantly, maybe there's going to be other stuff here, right? Like blog category or something like that, right? And all of those things will be rewritten as far as your service is concerned, to look like this.
Okay.
Right. So that this /blog part will be chopped out of the URL for you and have that stuff appended on the end.
Yeah, that's cool, because when you have those monoliths, like you do this routing in your application, so you do this filter by modules inside your application, and here like you have microservices, and then you are running filtering these in the one layer before. That's cool.
Exactly. Yeah. And so, and one of the reasons that we built this was that for Contours one, you don't for HttpProxy, this doesn't need to live in the same namespace. Okay, this can live in the marketing namespace, and the API one can live in a separate namespace. And so what that means is that instead of everybody needing to have access to the default namespace to be able to manage their own app, you can say to people, okay, marketing team, as long as you have a service that's called blog in your marketing namespace, then this HttpProxy will route traffic to that service. And so it's up to you what you do with it. You can have, you can swap the version out, you can upgrade the version, all that sort of stuff. The HTTP route will ensure that the routing keeps going consistently to that service. If you remove that service, then your blog will disappear, right? Like /blog will be a 503. But it's up, that sort of allows the marketing team to do some stuff themselves, and the API team to do some stuff themselves. Yeah.
Yeah. So this HttpProxy make it happen across the namespace. Otherwise,
yes, exactly.
It can only access the resource within its namespace.
Yeah. So if you look at the Ingress one, in this service field, there's no field for namespace. You can't put a namespace here and have it work. It's just it's not a valid field. There are very good reasons for that. Doing this sort of cross namespace reference is actually can be a security risk, right? Because if you imagine that we're doing something else here, right? Like I'm Johnny McHacker and I get access to the default namespace, and I find out that the payroll system is running in the payroll namespace, right? And the service is called payroll, right? By changing the thing to that, I have now exposed payroll on bar.com/blog, right? Like, so that, because the person who owns this has a lot of power to sort of expose anything that they have a reference to, right? So there is a security risk here that needs to be managed. Now, one of the ways that you can manage that is another thing that we built into HttpProxy called a route inclusion, which basically what it essentially lets you do is break up these chunks, the service chunks, and put them in their own HttpProxy object that lives in your namespace. So what would that look like? Well, what that would look like is something like this. So there's an include stanza available here, like this, that lets you it's a list, and it has conditions like right, and then here you do hang on, I've got to look up the spec, it's been a little while. it is blah, 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 includes namespace. Yeah. So and then you just have what that lets you do is have a HTTP proxy here called blog in the marketing namespace. But then we'll have okay, now you don't need to have the prefix because the prefix is actually check this out. Actually need any of that. Okay, what this is actually doing is this is saying include the HTTP proxy in the marketing namespace with the name blog, and for all the paths inside it, wrap those paths with this /blog. Okay, and so when you do this, you can have your blog namespace in your blog HTTP proxy in your marketing namespace, and now you as the marketing team own this whole HTTP proxy, and as long as this HTTP proxy exists, you can put whatever you like in here. Most importantly, you can do stuff like this. So as far as this default namespace thing is concerned, I'm just routing to this HTTP proxy. But this HTTP proxy says, okay, we've got 2 services we want you to serve traffic out of. I want you to send 90% of the traffic to the blog one and 10% of the traffic to blog v2. What this lets you do is like a sort of canary style deployment where you direct some traffic to the blog v2 service and make sure that everything is working as you expect, and then you can change these weights and sort of gradually change them back so that eventually you end up with 100% here and 0% here, and then once you're happy with that, then you cut the old one out and you've done a seamless canary style upgrade. But the good part is that the API team in this case, they don't need to care about any of that, right? Like that's none of their business. That's all your business because you've broken out this the /blog prefix and given it to and delegated it in some ways to the marketing team in the blog HTTP proxy, and then it's up to the marketing team exactly how they manage that.
That's really cool.
Yeah, and so some of this stuff is just not possible in the older Ingress object, and what you'd find is pretty much every Ingress controller that has been around any length of time has either something like annotations like Ingress Nginx does, or their own CRD that's similar to this that does the same things, that lets you do weighted load balancing, that lets you break up the config more clearly, lets you sort of share the config between different people, and most importantly, stops. One of the biggest things that we wanted to do was to stop people inadvertently clobbering each other. Now you can see here, this Ingress object lives in the default namespace, but the host name is kind of owned by everybody. So if you create, if mine's the default namespace and Chinchi yours is the Chinchi namespace, then and you create another contour test one that also matches the host contour test 1.yongnik.dev, what will happen in that case is kind of undefined, right? Ingress Nginx will actually load balance the 2 services. So if I specify my echo service and you specify your echo service, then the traffic will be load balanced between them. And if we both specify different paths, then it'll all just kind of work. But what it means is that people can inadvertently clobber other people's config just by creating an ingress in the one that you own. And so that's one of the reasons why we have this sort of delegation thing in HTTP proxy, to stop people doing that, right? To stop it, to make it so that you can't do it. You have to, only one HTTP proxy can have the bar.com FDN, right? If you try and have 2, then there'll be errors on both of them and nothing will work. And so, yeah, that's a very deliberate decision we made to sort of, because when we were building this, we had lots of people who were running multi-tenant clusters, and we wanted to make it so that that problem couldn't arise.
This HttpProxy really empower the Ingress resources. It has like many other functionality and benefits of using that.
Yeah, and so we sort of started this process, man, it's like over 3 years ago now. That we started building out HttpProxy in Contour, and I mean, if we are okay, it's actually a really good segue to talk a little bit about Gateway API if we have enough time, or are we running out of time?
Oh, we have 10 minutes left.
Okay, so I can quickly talk through why the Gateway API ended up existing, and then we can talk through the details of the Gateway API another time. So, Contour is here building a HttpProxy. Solo and the folks building Glue, they have their own set of CRDs. The Istio folks have their own set of CRDs that do the same thing. It's a little bit more complicated because Istio has more depth to it. Who else is there? Kong, and a bunch of other folks are all solving this same ingress problem, and everyone was sort of inventing their own CRDs to describe the same things. So at KubeCon San Diego in 2018, we had a big meeting with a whole bunch of ingress controller maintainers and sort of said, hey, maybe we should all try and pull our efforts here and build something in the upstream that's like Ingress. It's an upstream API that we're all going to agree on, but it's going to have all of the power of all of these CRDs. And at the time, we called it it was called Ingress v2, but it quickly evolved that we wanted to be able to handle layer 4 use cases, so TCP and UDP directly rather than just HTTP. And so we renamed it to the Services API, and then people found that confusing. So we renamed it again to the Gateway API. And so the Gateway API now is the upstream effort to take this sort of functionality that you have in this HttpProxy and make it standard, and make a standard way to do this that everybody can do. That in an ideal world, for simple use cases, I mean, this is what I'm talking about here with wanting to do wanting to split things up on the basis of teams and one team wanting to do a weighted load balance. Like, this should be pretty straightforward. This is a reasonably common use case. It should be reasonably easy to do this. And if you're using the Gateway API, one of our goals for the Gateway API is that if you're using Contour and you use the Gateway API and you describe something like this, you can take that exact same Gateway API config and change it to Kong or Ingress or Nginx once they support the Gateway API, or some other thing that supports the Gateway API, and it will just work. You can literally just take that exact same config and be doing the same thing here where you're running two gateways. You can take the routes, the HTTP routes, and point them to both gateways at once, and everything will work. And the same service will be exposed on two different gateways, two different ingress controllers, and everything will work. And there's nothing that you need to change to move between ingress controllers. That's the goal of the Gateway API. That's where we want to get to.
So, for the Gateway APIs, like Contour and not the other controllers will be responsible still to parse and read the CRDs, or?
Yes. So Gateway API is a little weird. Hang on, I'll stop the stream here. Gateway API is a little weird in that it's a upstream API that's delivered using CRDs, right? So it's an upstream API in the same way that Ingress, Service, Pod, Deployment, Node, all of those APIs are. We go through Kubernetes API review and all of the same stuff that a core one does, but we deliver the actual resources with CRDs. And so these are kind of like blessed CRDs, upstream CRDs. We're only the first to do this. Other people have started looking at doing it for bunches of other places. But so what that means is that in order to use the Gateway API, first thing, you have to install the Gateway API CRDs. Second thing, you need to install an implementation that can reconcile the Gateway API CRDs for you. When you do that, in similar way to the Ingress, you install a gateway class that sort of tells you about the controller that's going to be reconciling those gateways. Then you create gateways, and now a gateway describes the ports that it's going to listen on and the addresses that it listens on. And then you add routes which describe how the traffic that is associated with a listener on a gateway will be routed to services. And so we break apart the config even more. Like even in HttpProxy, you have like one object that handles like all of those responsibilities. in the gateway API, we kind of break it up a bit so that then different people can own the different chunks. So I can be an infrastructure admin, and my job is to install the gateway API, CRDs, and a controller that will reconcile them. I own the gateway class. Then, Amim, you can be the sort of the cluster admin, and you can say, okay, I want to set up a gateway that's going to expose, that's going to be available for people to associate their HTTP routes to. And then so that's your job. And then Chichi, you then own the HTTP route, and you're like an application developer, and you can say, okay, I want to expose my app on this listener, on this domain name, in the same way that you do with Ingress. But it means that we've sort of broken up the different responsibilities in a really clean, logical way that's also part of the actual API itself.
Yeah, this model is similar with the issue one, right? I have seen this gateway and routes and CRDs in Istio. I think it's a good one.
Yeah. So it's a little bit similar to what they've done. They've sort of broken things up into gateway and routes as well. But we also took inspiration from like storage class and storage class and PVs and PVCs and stuff like that, where where there's this very clear hierarchy of objects, and different people can own different bits of the hierarchy. And so that's sort of the drivers for why we were sort of looking to build a gateway API. Now, I kind of don't want to actually get into showing too much of the YAML of that, because it's its whole own thing. It's pretty complicated. There's a lot to take in there. And so, I kind of would rather leave this one just to be sort of, let's talk about Ingress and then the path to gateway, and then we'll save gateway API for another day, because it's a whole hour easily by itself.
I will stop doing questions because I have a lot of...
That's fine. I think we've got a few minutes left, right? Like, if no one else is asking questions, then ask away, right? Like, I think that's fine.
Yeah, I think that for the audience, so whoever have any questions, you can find Nick in the project the Slack channel, right? Project Contour.
On Kubernetes Slack, we're in hashtag Contour. I'm Young Nick on Kubernetes Slack. I'm Young Nick on Twitter as well, so please feel free to ask me questions there. But if you have Contour related things, Contour, hashtag Contour on Kubernetes Slack. Also on Kubernetes Slack, there's the I think it's SIG Network Gateway API or something like that. Let me just check the name. Hang on. It is hashtag SIG-network-gateway-API is the Gateway API channel. And so if you go in there, there's plenty of people asking questions about and sort of trying to get everything working for the Gateway API. We're still very early days for the Gateway API. But that's the place to go to ask questions.
So what's the plan for Contour? What's the next big deal?
So for Contour, we're going to be continuing. We've had some. There's been some big developments recently, actually. So the Envoy project has recently started an Envoy Gateway project, which is basically an official Envoy branded controller to reconcile Gateway API objects. And so the Contour maintainers, the VMware Contour maintainers, are involved in this project. And practically in the future, like when Envoy Gateway is GA, by that time, hopefully the Gateway API will be GA. And at that point, sort of further growth in that thing will be done with Envoy Gateway. So at some point in the in a number of years, Contour will sort of move into maintenance mode. That is in a number of years, though. I need to be very clear. Like right now, we're continuing to development on Contour just like we normally would, because we've got to wait for to see what happens with Envoy Gateway. Contour's Gateway API implementation is proceeding. We are currently a conformant gateway implementation. So the Gateway API has its own set of conformance tests, just like Kubernetes, and Contour currently passes all of those. Or if it has a couple that it doesn't pass, it will very soon. We're keeping it up to date. And the aim for Envoy Gateway is to make it also a conformant implementation, and then we will gradually transition a lot of the development resources we're using on Contour to developing Envoy Gateway in terms of VMware. I think that the future for Contour is, it is mostly a completed product. Like it does everything we need it to do. It's going to work. It is going to be supported until people are not using it. So VMware have committed that it's all going to be supported until people are not using it. But yeah, the future for Contour is that it'll be around for a while. Envoy Gateway will come along, is coming, and the Gateway API support will continue moving until we can get it to GA. That's the goal. That's bring that stuff to GA and have it be a standard Kubernetes API that everyone loves and everyone's using.
That's very awesome.
Yeah, pretty cool.
Pretty good. Yeah, looking forward to that. And since we are running out of time, so thanks everyone for watching our episode, and big thanks to Nick Young and Amin for joining us today and share this awesome knowledge about Ingress and HttpProxy and also Gateway API with us. And looking forward to our follow-up episode. Thanks everyone. See you next Wednesday.
Thanks for the chance.
Bye-bye.